In this video, we're going to talk about section 1.5 dealing with quadratic equations. Okay, now in previous videos, we talked about linear equations and how to solve them. This time, we're going to talk about quadratic equations. And that is where the exponent, the highest exponent, is a 2. And here in this section, we'll talk about how to solve quadratic equations by factoring, by using the square root property, by completing the square, and by using the quadratic formula. Okay, so we're going to look at 4 different methods of solving quadratic equations. Also, we'll use the discriminant to determine the number and type of solutions. Okay, so first of all, let's define what a quadratic function is. A quadratic function is an equation in X, by the way, that can be written in the general form. So this is the general form for the quadratic equation, ax squared plus bx plus c equal to 0. And that's where a and b and c are real numbers, and a cannot be equal to 0, because if a was equal to 0, then that means we wouldn't have a quadratic equation. We will end up with a linear equation. A quadratic equation in X is also called a second-degree polynomial equation in X. Reason being is because the highest exponent there is a 2. So second-degree polynomial equation, or we'll just say quadratic equation. Now, we're going to look at 4 different ways of solving the quadratic equation. The first method is by using a method called factoring. And when we do factoring, we're going to use what they call the zero product principle. And that's this: if the product of 2 algebraic equations is 0, then at least one of the factors is equal to 0. So in short, let's say A and B are 2 algebraic expressions. If the product of A and B is equal to 0, then that means either A is equal to 0 or B is equal to 0. Okay, so we're using that zero product principle in this case. Once after we do the factoring, we'll use that zero product principle. And this is the method for solving a quadratic equation by factoring. If necessary, you might have to rewrite the equation in general form by moving all the terms to one side and obtaining a 0 on the other side. Okay, that's the first thing you might have to do. Get a 0 on one side by moving terms over to the opposite side of the equation. And then number 2, you're going to factor completely. You might have to use various methods of factoring, like looking for a common factor, or you may have to factor into 2 binomials, or you may have to use differences of 2 perfect squares. You might have to factor that as a sum and the difference of 2 terms. And then apply the zero product principle that we just got through talking about by setting each factor equal to 0. And then step number 4 is to solve the equation in step number 3. And finally, check your proposed solutions in the original equation. Okay, because you want to make sure that your answers do make sense, or they satisfy the equation. All right, so now let's take a look at this first example here. Let's say we got 3x squared minus 9 is equal to 0. And we're going to solve this by factoring. Okay, well, by looking at this, I only got 2 terms here, and I've already got a 0 on the opposite side of this equation. So we don't have to worry about moving terms over to the left side. In this case, we need to do some factoring. I got 2 terms. So let's look for a common factor that's in 3x squared and 9x. Well, for the numbers, we need the largest number that goes into 3 and into 9. In this case, has to be 3. So I know I'm going to factor out a 3. Now for the variables, we take out the common variable with the smallest exponent. In this case, it's the x to the 1. So 3x is going to be the common factor. Now to get what's inside the parentheses, excuse me, to get what's inside the parentheses, I divide each term by the greatest common factor. So when I do 3x squared divided by 3x, I'll end up with x, and then minus 9x divided by 3x. That'd be 3. So here I got 3x times the quantity x minus 3 equal to 0. So this is factored completely. And then number 3, we're going to set each factor equal to 0 and use the zero product principle. So in this case here, 3x times x minus 3 equal to 0 means this. 3x is equal to 0, or x minus 3 equal 0. And then for each equation, we're going to solve for x. So for 3x is equal to 0, if I divide both sides by 3, that means x is equal to 0. Or for the x minus 3 equal to 0, if I add 3, I write the word or here, x is equal to 3. So these are my two proposed solutions, x equals 0 or x is equal to 3. Okay. Now to verify that, we'll go ahead and do the check on our proposed solutions here. And I'll start with x is equal to 0, which is going to be quite easy. So here we just substitute each x with 0 in this equation. So we got 3 times 0 squared minus 9 times 0. I want to know if that's going to be equal to 0. Well, 0 squared is 0. 0 times the 3 in front is going to be 0. Minus 9 times 0 is 0. And of course, 0 minus 0 does equal to 0, so that checks. So I know here that x equals 0 is a solution. Also, I'm going to do the check for x equal 3. In this case, I'll write the original equation and substitute each x with 3. So I get 3 times 3 squared minus 9 times 3 equal to 0. Well, if I square the 3, that's going to be 9. 9 times this 3 in front will be 27. Minus 9 times 3, that's 27. 27 minus 27 is 0. So both of these x values are solutions to this equation. So here, the solution is just going to be these two numbers, 0 and 3. And if you notice the highest exponent there is 2, that means that there are supposed to be 2 solutions to this equation because it is a quadratic equation. Okay. Here's another example. 2x squared plus x equals 1. And here I want to solve this equation by factoring. Okay. So the first thing I need to do here is write the equation in general form, meaning I need a 0 on this side of the equation. And to do that, I need to subtract 1 on both sides. So that means I'm going to have on the left side 2x squared plus x minus 1. And that's equal to 0. Now the next step would be to factor this into 2 binomials because I have 3 terms here. So the best way I'm going to have to do this is factor into 2 binomials. Now for the 2x squared, I need to break that up as 2x times x. Now the only factors of minus 1 will have to be positive 1 and negative 1. Now I need to put the plus 1 and the minus 1 in the correct places so that the outer and the inner will give me a sum of positive 1x. Well, let's do this. I'm going to put the plus 1 where that x is and the minus 1 where the 2x is. When I do that, the outer will be 2x, the inner will be minus 1x. 2x minus 1x will give me the middle term of x. So you have to make sure that you're placing your numbers in the right place so that the outer and the inner will give you the middle term. So factor completely, this is 2x minus 1 times x plus 1 equal to 0. Now the next step would be to set each factor equal to 0 using the zero product principle. So this means 2x minus 1 equals 0 or x plus 1 equal 0. So here I have two equations. Now each equation I'm going to solve for x. So starting with 2x minus 1 equal to 0, if we add 1 to both sides, that means 2x is equal to 1. Divide both sides by 2. That means x is equal to 1/2. And now for the x plus 1 equals 0. Of course, if I subtract 1, you'll get x is equal to negative 1. All right. Now, of course, we're going to do the check. Starting with x is equal to 1/2. And this is the original equation that I'm using. So I substitute each x with 1/2. So there'll be 2 times 1/2. That has to be squared plus this x is substituted with 1/2. I want to know if that's going to be equal to 1. Let's see, if I square the 1/2 by squaring the numerator and the denominator, I'm going to have this 2 times 1 squared will be 1 and 2 squared will be 4. So that's 2 times 1/4 plus 1/2 equals to 1. Now that 2 is like 2 over 1. And if I simplify this, this 2 goes into that 4 2 times. And of course, 2 goes into itself 1 time. 1 times 1 will be 1 over 1 times 2, which will be 2. So I got 1/2 plus 1/2. I want to know if that's equal to 1. Or 2 halves do make up a whole, so 1 does equal to 1. That checks. And now for x equal negative 1. We'll substitute each x in that original equation with negative 1. So I get 2 times negative 1 squared plus negative 1. I want to know if that's going to end up being equal to 1. If I square a negative, that's going to be positive. So negative 1 u squared will be positive 1. I'll just write the rest of this down. And then 2 times 1 is 2. 2 plus negative 1 is a positive 1. So that checks as well. So I can box in the x equal negative 1. So here again, I had two solutions here for this quadratic equation. And that's going to be 1/2 and negative 1. Okay. Okay, here's one more of these. Like x squared is equal to 3x plus 10. And here I want to solve this quadratic equation. Well, it's not written in general form, so that means I need to move terms over to the other side so I can get a 0 on one side of this equation. So I need to move the 3x and the plus 10 over to the other side. I'm going to do that by subtracting 3x and subtracting 10 on both sides. So when I finish this, I'm going to bring down the x squared. I'm going to put that in front. And then minus 3x and minus 10 equal 0. So now I have a 0 on the right side and all my terms on the other side. So this quadratic expression, I can go and factor this into 2 binomials because I got 3 terms. The x squared breaks up as x and x. And then I need factors of negative 10. That's going to give me a minus 3x. Okay. Notice that the middle term is negative and the last term is negative. So one of them has to be plus, the other one has to be minus. And I'm going to have to break 10 up as 5 and 2. And keep in mind, the larger of the two factors takes the sign of the middle term. And in this case, the 5 will have to be minus, and the 2 has to be plus. So that means we're going to have x plus 2 times x minus 5 is equal to 0. Okay. And then we set each binomial factor equal to 0. So this means x plus 2 equals 0, or x minus 5 equals 0. And each equation we're going to solve for x. So for the x plus 2 is equal to 0. If we subtract 2 on both sides, that means x is equal to negative 2. Or for the x minus 5 is equal to 0. If we add 5, you'll get x equal 5. Okay. Now, of course, I'll go ahead and do the check for these. Using let's start with x equal negative 2. And my original equation is x squared equal 3x plus 10. Substitute each x with negative 2. I'll have negative 2 squared. I want to note that's going to be equal to 3 times x equals negative 3 times negative 2 plus 10. Square the negative 2. That's like negative 2 times negative 2, which is 4. Well, note that's equal to 3 times negative 2 is negative 6. Negative 6 plus 10 does give me 4, so that checks. And now for the x equal 5. Using the original equation that I started off with, we'll substitute the x with 5, so I get 5 squared. My equals 3 times x, which is 5, plus 10. 5 squared, or 5 times 5, is 25. I want to know if that's equal to 3 times 5, which is 15. And if I add 15 and 10 together, I would get 25, so that checks. So here I had 2 solutions for this quadratic equation. Negative 2 and 5. Okay, so that's how we solve quadratic equations using the method of factoring. Now, if your factoring skills are not up to where they're supposed to be at, there are YouTube videos there that can help you with factoring. And in Canvas, I did post a link to one of the YouTube channels that focuses on one of the concepts in mathematics and in algebra, and that's factoring. Okay. All right, let's look at the second method, and that's solving by using the square root property. The square root property states that if U is an algebraic expression and D is a non-zero real number, then U squared equals D has exactly two solutions. And that's this. If U squared is equal to D, then U is equal to the square root of D, or U is equal to minus square root of D. And equivalently, we can shorten this by using the plus or minus symbol. Okay, we can do that with the plus or minus symbol, but I do need to warn you, in my math lab, they don't have that plus or minus symbol, so you have to enter your answers as two separate answers. One will be positive, the other one will be negative. Or one will have a plus in between or the minus in between. So in this example here, there are three parts here. In each part, you're going to solve by the square root property. Like 3x squared minus 21 equal to 0. So what we're going to try to do is get x squared by itself and then take the square root on both sides. Okay. So let's try to do that here. Because this is 3 times x squared minus 21. Let's get rid of the minus 21 first by adding 21 on both sides. So that means we got 3x squared equals to 21. And then to get x squared by itself, we're multiplying it by 3. We need to divide both sides by 3. So that means x squared is equal to 7. And we're squaring it. The opposite of squaring something would be to take the square root. So that's what we'll do here, is take the square root on both sides of this equation. And when we do that, we need to include the plus or minus symbol. That's always the case. Anytime you take the square root on both sides of an equation, you need to include plus or minus. So the square root of x squared is x, and that's equal to, now 7's not a perfect square because I can't find a whole number squared that's going to give me 7. So we have to leave that as plus or minus the square root of 7. Now, as your solution, you're not going to be able to use that plus or minus symbol in my math lab. So you have to enter this as two separate answers. The square root of 7 and negative square root of 7. So my two answers are the square root of 7 and negative square root of 7. And no, don't worry about the check either. All right, let's look at the next example. 5x squared plus 45 equals to 0. And we want to solve this equation as well. So we have to do the same thing we did in part A, get the x squared by itself. So first of all, we need to do something with the plus 45, and that is subtract 45 on both sides. So here, we got 5x squared is equal to negative 45. And then to get the x squared by itself, we're multiplying it by 5. We need to divide by 5. So here we got x squared is equal to negative 9. And then to solve for x, we're squaring it. So that means we need to take the square root on both sides. And don't forget, we need to include that plus or minus symbol every time we take the square root on both sides of an equation. So the square root of x squared is x. That's equal to plus or minus. Now the square root of negative 9. You have to think about this when we were dealing with complex numbers. Of course, the square root of 9 is 3. but the square root of a -1 is I. Because of the negative underneath the radical, that means there is -1, and the square root of -1 is I. You might have to watch the video for section 1.4 to understand the imaginary unit, I, because we did talk about that in that last video. So x will be equal to plus or minus 3i, but of course, at the end of this as two different answers, 3i and -3i. Now take a look at part C. Here we got x plus 5 quantity squared is equal to 11. And here we want to solve this equation. This one's written differently from parts A and B because if you look at it, we take the x, we're adding 5 to it, and then we're going to square it to get 11. Now we got to do the reverse using inverse operations. We first need to get rid of the square that's out there. The opposite of squaring something will simply mean we need to take the square root on both sides. And of course, we include that plus or minus, and then we take the square root of 11. Now, the square root of x plus 5 quantity squared, what that square root does, it eliminates that exponent of 2. Because squaring and the square root are inverse operations. So we'll be left with x plus 5. And then that's equal to plus or minus the square root of 11. 11 is not a perfect square. Now we can solve this equation for x. We're adding 5. So the opposite of adding 5 would have to be to subtract 5 on both sides. So I do have x by itself. Now notice that the minus 5, but I got that 11 underneath the radical, so I can't combine like terms here. I can't do -5 plus 11 because that 11 is underneath the radical. So the best way I can write this as x equals -5 in front, and then plus or minus the square root of 11. And since there are no plus or minus symbols in my MATLAB system, I have to enter this as two separate answers. One would be -5 plus the square root of 11, and then -5 minus the square root of 11. Okay. So that's how we use the square root property to solve quadratic equations. Okay, the next method is completing the square. Now, we cannot use the zero product principle in such a case where the trinomial of the form ax squared plus bx plus c cannot be factored. However, we can convert the equation into an equivalent equation that can be solved using the square root property. This is accomplished by completing the square. And this is the method of completing the square right here. If you have x squared plus bx as a binomial, then if we add the square of b over 2, which is the square of half the coefficient of x, a perfect square trinomial will result. And that is this. We add the b over 2, and that's going to be squared. Half the coefficient of x, and that'll be squared. And then when we factor it, it's going to end up like this, x plus half the coefficient of x, and that quantity will be squared. Okay. So here in this example, we're just going to get our feet wet with using that concept of completing the square. And that's going to be this right here. What term should be added to each binomial so that it becomes a perfect square trinomial? So here you're going to write and factor the trinomial in this case, starting with x squared plus 6x. X squared plus 6x. The b is going to be the coefficient of your x term, which is in this case 6. So in this case here, we have to do b over 2, and that's squared because that's what we're going to have to add to this binomial. And b in this case, that should be the coefficient of x. That's 6. So this would be 6 divided by 2, and that's squared. And then if you take half of 6, which is 3, square that 3, you're going to get 9. So that means we're going to have to add that 9 to the x squared plus 6x. Okay? So I'm going to bring this down, x squared plus 6x, and then I'm going to add 9 to it. That would be my perfect square trinomial. Now to factor this, it's going to follow this format right here. It'll be x plus, your b is 6. So 6 divided by 2, or half of 6, is going to be 3. And then we tack on the square on the outside. So x squared plus 6x plus 9 will end up being the quantity x plus 3 squared. Okay. Now let's look at part B. We got x squared minus 5x. In this case here, our b again, well, our b this time is going to be negative 5. That's the coefficient of x. So we need to know what b over 2 quantity squared would be. And b is negative 5 in this case. So I'm going to do negative 5 over 2, and that's going to be squared. Well, if I square the negative 5, that's going to be positive 25. And square the 2 in the denominator, that's going to be 4. So I'm going to have to add 25 over 4, or 25 fourths, to this binomial. So this is going to be x squared minus 5x plus 25 over 4. That would be my perfect square trinomial. And if I was to factor this as the square of a binomial, of course, it's going to have, bring that down, this format again, which is in this case, x. And this time, the middle term is a minus, so that means I'm going to have a minus sign in between, in the parentheses. And that b over 2, that was negative 5 halves. I'll just bring down the 5 halves. Because you could do this, x squared plus, and then negative 5 halves, but you'll have to write it as, and that's going to be squared, by the way, but you're going to have to write it as x minus 5 halves, quantity squared, if that helps. Okay, finally, part C. Here we got x squared plus 2/3 x. And here I want to find out what number I need to add to this, so I'll have a perfect square trinomial. So here my b is the coefficient of x. That's 2/3. So to find b over 2, quantity squared, the b is 2/3. And I'm going to write this as 2/3 times 1/2. And that's going to be squared. Reason why I'm doing that, because actually you are taking 1/2 the coefficient of x. My coefficient of x is 2/3. You're going to have to multiply that by 1/2. And let's simplify this. Let's see here. These 2's divide out in the numerator and the denominator. So that means I had 1 times 1, which is 1, divided by 3 times 1, which is 3. That'd be 1/3 squared. Square the 1, you're going to get 1, and square the 3, you're going to get 9. So I need to add 1/9 to that binomial. So I have x squared plus 2/3 x plus 1/9. And that's going to have to be factored as a square of a binomial, which is going to fall into this format right here, x, and then plus, let's see, the b over 2 was this right here. The b over 2 was this number that's inside the parentheses. That's the 1/3. So I get x plus 1/3 quantity squared as the square of a binomial. Okay. Now we're going to use that particular idea when we're dealing with quadratic equations using the concept of completing the square. Okay. I was able to find this technique for solving a quadratic equation by completing the square. Now, if you want to, you can pause this video and copy down the directions or the procedure that's in this yellow box here. So to solve ax squared plus bx plus c equal to 0 by completing the square, you're going to do these 4 steps. Number 1 is this: if a, which is your leading coefficient, is not 1, you're going to have to divide both sides by a. This makes the coefficient of the x term 1, because you want the coefficient of your x squared term to be 1 before you begin the next steps. And step number 2 is to isolate the variable terms on one side of the equation and the constant term on the other side of the equation. And then number 3, complete the square by adding the square of 1/2 of the coefficient of x to both sides of the equation. And then you're going to factor the resulting perfect square trinomial. And then step number 4 is use the square root property and solve for x. Okay, that's the procedure. Now, if you want to, you can pause this video and write down that procedure. Okay, now, on our handout says that when you add a constant term to one side of the equation to complete the square, be certain to add the same constant to the other side of the equation as well. So let's solve by completing the square. In this case, x squared plus 4x minus 1 is equal to 0. Okay, notice my x squared term is already an understood 1 there, so I don't have to worry about dividing through by some number because the coefficient of my x squared term is 1. But let's go ahead and get the x squared and the 4x by itself and move the constant terms over to the other side. Here I'm subtracting 1, so I need to add 1 to both sides. So that means I get x squared plus 4x equals 1. And now I'm going to go ahead and complete the square. So here's what we need to do here. To find the term that we need to add on this side and on the other side, we need to take 1/2 the coefficient of x. 1/2 of the coefficient of x and square it. So off to the side, I'm going to do 1/2 of 4, and that's squared. 1/2 of 4 is 2, and then 2 squared would be 4. So in this case, on the left side, I'm going to add 4 to both, add 4 here. And if I add 4 on the left side, I also have to add 4 on the right side. Okay. So on the left side, I got x squared plus 4x plus 4, and that's equal to 1 plus 4. The left side, I'm going to factor this as the square of a binomial, because that's what that means. Of course, it's going to be in the form of x plus 1/2 of 4. That's the b over 2. 1/2 of 4 came out to be 2, so that 2 goes here. So it'll be x plus 2 quantity squared equals 5. And now we're going to use the square root property to solve this. I'm squaring this, so the opposite of squaring something would be to take the square root on both sides. And of course, we include plus or minus as well when we take the square root of both sides. Now, the square root of x plus 2 quantity squared would just simply be x plus 2. That's equal to plus or minus the square root of 5. And to solve for x, I'm adding 2. I need to subtract 2 on both sides. So that means x is equal to -2 plus or minus the square root of 5. And of course, you'll have to enter this as 2 separate answers, by the way. That's going to be -2 plus the square root of 5, -2 minus the square root of 5. Okay, now this next example, this pretty much reiterates that procedure that I gave you. If the coefficient of the x squared term in a quadratic equation is not 1, you must divide each side of the equation by this coefficient before completing the square. So like here, we got 2x squared plus 3x minus 4 equals to 0. Now, notice that the coefficient of the x squared is not a 1, it's a 2. We need to make that a 1x squared coefficient. So to do that, I need to divide each and every term in this quadratic equation by 2. So when I do that, 2x squared divided by 2 will be x squared. Plus, this will be 3 over 2 times x minus 4 divided by 2 will be 2 equals 0 divided by 2, which is 0. So that equation has a coefficient of 1 in its x squared term. Now, I need to isolate all the variables that have an x in it on one side and the constant term on the other side. I need to move the -2 over to where that 0 is by adding 2 on both sides. That means x squared plus 3/2 x equal 0. And now we can complete the square. Now to do that, we have to take 1/2 of the coefficient of my x term, which is 3/2, and that's going to be squared. Well, let's evaluate 1/2 times 3 over 2. That's going to be 3/4. Numerator times numerator, denominator times denominator. So 3/4, and if I square that, 3 squared will be 9 over 4 squared, which is 16. So I'm going to be adding 9/16 to both sides of this equation. So this will be plus 9 over 16 here, and plus 9 over 16 on the right side. Whatever I do on one side, I must do the same thing on the other side. And now we're going to factor this as a square of a binomial. Okay, which follows the format with the x, and then plus the b over 2 cannot be 3/4 here. So this will be x plus 3/4 quantity squared. That's equal to 9/16. 0 plus 9/16 is 9/16. And now we can solve for x here. This is being squared, so the opposite of squaring something would be to take the square root on both sides. And of course, we include that plus or minus symbol. So that means here, the square root of x plus 3/4 quantity squared is x plus 3/4. That's equal to plus or minus. Notice that the 9 and the 16 are perfect squares. I can take the square root of the numerator and the square root of the denominator. The square root of 9 is 3 over the square root of 16. That will be 4. Okay. All right, now, okay, I need to make a correction on this example. When I added 0 plus 2, this should be a 2 right here. And then this will be 2 plus 9/16, which will not be 9/16. Okay. Okay. And I'm going to show you how to do 2 plus 9/16 in your calculator. This will be 2 plus, and then 9 divided by 16. And then press your math key and select number 1 for fraction. This will be 41/16. Okay. And then, of course, the opposite of squaring something will be to take the square root, and I do need the plus or minus. So this will be the square root of 41/16. So here I'm going to have plus or minus. Now, the square root of 41, I'm not going to be able to take that to get a whole number, take its square root to get a whole number. So I'll leave that underneath the radical, but I can take the square root of 16, which will be 4. Okay. So I get x plus 3/4 is equal to plus or minus the square root of 41/4. And now to solve for x, I need to subtract 3/4 on both sides. So my final answer will be this. X is equal to negative 3/4 plus or minus the square root of 41/4. And since my denominators are the same, I can rewrite this as negative 3 plus or minus the square root of 41. Whole thing will be over 4. So here, my final answer will be this, negative 3 plus the square root of 41/4, then negative 3 minus the square root of 41 all over 4. Okay. And for those who are watching this video, I do apologize for the mistake I made way up here. Okay. All right. So that's how you complete the square to come up with your solutions for your quadratic equation. But there is an easier way to do this, and that's going to be by using the quadratic formula. That will be the fourth method that we'll talk about, fourth and final method, using the quadratic formula. The solutions of a quadratic equation in general form ax squared plus bx plus c equal to 0 with a not equaling to 0 are given by the quadratic formula, which is this: x equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. Now, what I am going to show you is how they derive that formula. Okay. Now, I'm not going to go through the whole thing. Okay. And pretty much it's going to be very hard to put all of this in this screen with the limited screen size that I have here. But pretty much, if you want to, you can pause the video and then try to follow through with all of this. But that's just showing you how they derive the quadratic formula from the equation in general form. Ax squared plus bx plus c equal to 0, where a is greater than 0. Okay. Okay, so this is the quadratic formula that we'll use here, which is x equal negative b plus or minus the square root of b squared minus 4ac divided by 2a. Here, your equation has to be in general form first. The a is your coefficient of your x squared term, the b is the coefficient of x, and the c is the constant term. Okay, so let's start off with this example. Here we're going to solve using the quadratic formula, which is 2x squared plus 2x minus 1 equal to 0. And here I want to solve this using the quadratic formula. Well, I do have a 0 on the right side. That means it is written in general form. I can identify a, b, and c. So here a is the coefficient of the x squared term. That's 2. The b is the coefficient of x. That's also 2. The constant term c is negative 1. So here, I'm going to write down my quadratic formula. X equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then we're just going to substitute a, b, and c in that quadratic formula. So here, the b is 2. I got the negative in front, so that's negative 2 plus or minus the square root of b again, that's going to be 2, so that'll be 2 squared minus 4 times a, which is 2, times c, which is negative 1. That's all divided by 2 times a, which is 2. And now we're going to simplify all of this. Okay, I have negative 2, then that's plus or minus the square root of 2 squared, or 2 times 2, that's 4, minus 4 times 2, which is 8 times negative 1, which will be negative 8. But I got that minus sign, I will change that to a plus 8. All divided by 2 times 2, which is 4. Now, underneath the radical, 4 plus 8 is 12, so that's negative 2 plus or minus the square root of 12 all over 4. Now, let's simplify the square root of 12. In this case, there is a perfect square in 12 that goes into it. I need the largest perfect square that can go into 12. In this case, that's going to be 4. Because I know 4 goes into 12 3 times. So this is why I got negative 2 plus or minus the square root of 4 times 3 all over 4. And now I can take the square root of 4, which is 2. So I'm going to have negative 2 plus or minus 2 square root of 3 all over 4. Okay, now let's simplify this. Notice in the numerator, there's a 2 here and a 2 here. I can factor out the 2. I'm just taking out a common factor, which is 2. So the 2 comes out. So here, negative 2 divided by 2 will be negative 1, plus or minus 2 square root of 3 divided by 2. That's just square root of 3 all over 4. And now, if I divide 2 into itself, that goes 1 time. 2 goes into 4 2 times. So I'm going to end up with negative 1 plus or minus the square root of 3. I should say the square root of 3 divided by 2. Okay, so this is going to represent two answers. Negative 1 plus the square root of 3 over 2. Negative 1 minus the square root of 3 over 2. So those are my two answers there. And here's another example of that. Using the quadratic formula, we got x squared minus 2x plus 2 is equal to 0. So we're going to solve this using the quadratic formula. All right, so now we have a 0 on one side, so that equation is in general form. So I can identify a, b, and c. A is the coefficient of my x squared term. That's the understood 1. B is the coefficient of x, negative 2. And c is the constant term, is 2. And now let's use our quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac. Sometimes I'd say square root divided by 2a. Let's do our substitution here of a, b, and c. In this case, bring over that negative. The b is negative 2, so I get negative of negative 2 plus or minus the square root of b again is negative 2. That's going to be squared minus 4 times a, which is 1, times c, which is 2. All that will be divided by 2 times a again. That's going to be 1. Okay. Now to simplify this, all of this, negative of negative 2 will be 2, plus or minus the square root of 2 squared, negative 2 squared, or negative 2 times negative 2 will be 4, minus 4 times 1, which is 4 times 2, which is 8, all over 2 times 1, which is 2. Now, underneath the radical, 4 minus 8 is negative 4. So this will be 2 plus or minus the square root of negative 4 all over 2. And if I take the square root of 4, that's 2, and the square root of a negative 1, which is underneath that radical, that has to be I all over 2. Okay. Keep in mind, anytime you got a negative underneath the square root, the I comes out. All right. I'm going to break up 2 plus or minus 2i as 2 divided by 2, then plus or minus 2i divided by 2. You're going to see 2 divided by 2 is going to be 1, plus or minus 2 divided by 2 is also 1 times the I will be I. So my final answer there will be 1 plus or minus I. And my two solutions for this quadratic equation would be 1 plus I and 1 minus I. And keep in mind, these have to be in standard form. The real part first, and then the imaginary part comes behind it. Okay. And by the way, in the directions on the My Math Lab homework, you will be told which method to use, whether it is the factoring method or the square root property or completing the square or using the quadratic formula. You'll be told which one to use. Okay, finally, in this video, we'll talk about the discriminant, which is the quantity b squared minus 4ac. That's underneath the radical in that quadratic formula that we just got through talking about. What the discriminant tells us is the number and the type of solutions you will have. Okay, so in this case here, if your discriminant is greater than 0, you're going to have two unequal real number solutions. Well, two unequal real solutions, I should say. Or if it's equal to 0, then that means you got one real number solution. Or if it's less than 0, if it's negative, that means you have no real solution, which means you're going to have two imaginary solutions for your quadratic equation. Here's some examples of this. Here we're going to compute the discriminant and determine the number and type of solutions. So in part A, you got x squared minus 6x plus 9 equal to 0. Okay, so now we need to identify A, B, and C in this quadratic equation. X squared is coefficient is 1, that's what A is. The B is the coefficient of x, -6. C is your constant term, that'd be 9. So using b squared minus 4ac, substitute the b with -6, that's -6 squared, minus 4 times a, which is 1, times c, which is 9. Square -6, that's -6 times -6, that's 36, minus 4 times 1, which is 4, 4 times 9, which will be 36. And 36 minus 36 equal to 0. So here our discriminant is 0. That means that this quadratic equation only has one real number solution. Okay. Part B, we got 2x squared minus 7x minus 4 is equal to 0. We want to find the discriminant and determine the number and the type of solutions that we're going to have for this equation. Okay, in this case here, A is the coefficient of my x squared term, that's 2. The B is the coefficient of x, -7. C is the constant term, -4. Okay, and you want to make sure you do have a 0 on one side of the equation before you identify A, B, and C. And in this case, I have a 0 there. Okay, so the discriminant we're going to use b squared minus 4ac, and then substitute the b with -7. So it'd be -7 squared minus 4 times a, which is 2, times c, excuse me, which is -4. -7 squared is -7 times -7, that's going to be 49. Minus 4 times a -2, that's a -8, times that -4 will be a plus 32. Add 49 and 32 together, you'll get 81, which is a positive number. So that means we're going to have two unequal real solutions for this quadratic equation. Two unequal real solutions. Okay, and finally, part C. 3x squared minus 2x plus 4 is equal to 0. He'll want the discriminant and find out what the number and type of solutions we can have. So here the A is the coefficient of your x squared term, that's 3. B is the coefficient of x, -2. C is the constant term, that's 4. So here b squared minus 4ac is this. Your b is -2, and that's squared, minus 4 times a, which is 3, times c, which is 4. -2 squared is -2 times -2, that's 4. Minus 4 times 3 is 12, 4 times 3 is 12, 12 times 4 is 48. 48 from 4, or 4 minus 48, will be -44. So here I got a negative discriminant, meaning I have no real solution, or 2 imaginary solutions. So this has no real solution, which means there will be 2 imaginary solutions. And what I mean by that, it's going to have the I in it because of the square root of a negative number. Okay. Okay. So that will conclude this video on section 1.5, dealing with quadratic equations. Okay, and I'm sorry about the mix-up with one of the examples dealing with completing the square. But do feel free to email me if you have any questions about what's presented in this video and any questions about the homework for that section.